Okay, we are going to be super careful with this percentage question. Check this out. Suppose we know 70% of people like coffee and 80% of them like tea. We are going to find out what the minimum percentage would like both. So here's a super common mistake. So 70% is the same as 0.7 and 80% is the same as 0.8. And liking both means that the person likes coffee and also likes tea. It's an end situation. Maybe you can just multiply them together and we get 0.56, which is 56%. But I'll tell you, this right here is not correct. Why? Because, in fact, we don't know if we can actually multiply them together or not. Because we do not know if these two events are independent or not. Maybe for a person who likes coffee, he or she has a higher tendency of also liking tea. So in that case, they are not independent events. So do not multiply the percentage. And this is the reason why we are looking for the minimum percentage of liking both. So how do we approach this question though? Check this out. So first, I'm just going to give you guys an example, and then later on I will show you guys the actual math. So let's say we have a room of 10 people. So let me just draw the 10 people right here. Then, because we know 70% of them like coffee, 70% of 10 people is just 7 people. And I'm just going to put down the first 7 people who like coffee, and I'll just put down C if they like coffee. So that's what we have right now. Then we have 80% of them who like tea. Okay, I'm going to put down T for 8 people, but how am I going to do it? Well, if I just put down 1, 2, 3, 4, 5, 6, 7, 8, then you can see that this shows you what? It actually shows you the maximum possible percentage of the people who like both. Well, will be 7 of them, right here. Here's the deal. If 70% of them like coffee and 80% of them like tea, the maximum percentage of liking both is just 70%. These people, this person only likes tea, no coffee, and then no coffee, no tea, no coffee, no tea. Okay, but this does not answer the question though. I want to look for the minimal. So how can I arrange the T so that we can actually see the minimal who like both? Well, all I have to do is just erase this two, and then I'll put down all the T's right here. Now as you can see, only these 5 people like both. And in fact, no matter how you arrange the C's and also the T's, there will always be 5 of them with these overlaps, meaning they will like both coffee and tea. So as we can see, the answer to this question is just 50%. And we are done. Now let's see if we can actually approach this question in a more mathematical manner. Check this out. First, I'm going to show you what a Venn diagram is. And to do so, we see that we have 2 situations. So we are about to draw 2 circles, and then we ask ourselves, can they happen at the same time? Yes, we can totally have people who like both coffee and tea. So we have to make sure that the circles overlap. Here we go. That's why we have one circle right here representing the percentage of people who like coffee, and then this right here is for the people who like tea. And then in the middle, we can see that the overlap will mean the people who like both coffee and tea. And then we can draw a rectangle around it. If a person is somewhere right here, that means the person doesn't like coffee and does not like tea, neither. So that's a Venn diagram. Extremely useful when we're doing this kind of situations where we have the and or and also percentage and all that. Now, what we are going to do next is the following equation. Check this out. If we consider the percentage of the people who like coffee or tea, how do we come up with a formula for this? Well, first we will have to know how big this is. So that's the percentage of C. And then we are going to add that with the percentage of T. But be careful though. You see how when I did this right here, I actually included this part already. And then if I do this again, I will be including this part again. That's no good because that's double counting. So right here at the end, we will actually have to subtract the percentage of C and T. And this is the formula for the percentage or the probability of A or B, in this case, coffee or tea. Now, can we compute this? Yes, this right here is 70%, which is 0.7, and this right here is just 0.8, and this right here, okay, and of course we can add them out. That's just 1.5, and then minus P of C and T. But what's the left-hand side though? Let's think about it. The percentage of people who like coffee or tea, it was not given, but let's think about what's the maximum possible number for this. Well, if you consider the whole situation, then the maximum possible number for that, it would be just 1, which is 100%. And this means the people here, they must like either at least a coffee or tea. There's no other choice, and they cannot say no to these two either. So that's the maximum situation. So what we are going to get is the following. Because the maximum is equal to 1, so we know this right here has to be less than or equal to 1. Now let's subtract 1.5 from both sides. So that's negative P of C and T. That will be less than or equal to 1 minus 1.5. That's negative 0.5. Guess what we will do next? We divide both sides by negative 1. So yeah, we can cancel this, and then we can see that the percentage of C and T, remember, whenever we divide both sides by negative, we switch the inequality so it becomes greater than or equal to. This over that becomes positive 0.5, which is 50%. Have a look. This is exactly what we are trying to answer. Because this is always going to be greater than or equal to 50%, so that means the minimum percentage who like both is 50%. That's the answer.